Hey geometry class, we'll go ahead and get started with section 1.3. It's measuring and constructing angles. The two objectives here are name and classify angles, also measure and construct angles and angle bisectors. We'll go through this. We'll probably cover constructions another time, but the other two we should touch upon. Here you can see the list of vocabulary words. I imagine you're familiar with most of these. If not, I'll go through a couple of them that might be troublesome for you. Interior, think inside. Exterior, think outside. Straight angle might be one you haven't seen before. That's 180 degrees. Here you have some basic definitions of an angle. And the first thing, an angle is made up of two rays that share a common point. So here you can see ray RS and ray RT. They're both joined at point R, which is your vertex. It then goes on and says anything inside of this is the interior of the angle. Anything outside of it is the exterior. There's a few ways you can classify an angle. One is if it's just one angle, you can classify it by its vertex, which is angle R. You can classify it by three letters. The vertex is always in the center. So angle SRT is okay, along with kind of the flip-flop of that, angle TRS. If there's a number, you can refer to it as that also, angle 1. So here's 4 different ways you can call the same angle. Use the one that's easiest for you. The note on the bottom is a good point. You can't name an angle just by a vertex if there's more than one angle at that vertex. You'll see this on the next slide, so be careful with that. If you have something like the next slide, you're going to have to classify it by all 3 points. This slide shows an angle that has multiple angles at vertex A, so I can't say angle A in this example because I don't know if it's referring to this angle or this angle or even the largest angle, which is this one. So if you have this case, you got to classify them by the letters. So I've done 3 examples here. Things didn't transfer right, so I crossed it off on the left. But here you have angle BAC, which is this angle right here on the left, angle CAD, which is the angle here on the right, and then angle BAD is this large angle. Just like with the ruler postulate, you get the same thing here. It's the protractor postulate. I can let you read through it here, but basically it's saying with this, you can now measure degrees of an angle. Similar to the distance formula of yesterday, you get the same thing with a protractor. It's the absolute value of D minus C, or you can flip-flop that and say the absolute value of C minus D. Be careful when you're measuring angles. Make sure if it's acute, it's less than 90. If it's obtuse, it's greater than 180. So example here, I have this angle AOD. If you look here, it says 75. Well, that's incorrect. This is an obtuse angle. So here you're going to have to use the bottom scale. It looks like it's about 115. So just be careful when you're reading the protractors. Here you have the 4 different types of angles you'll see. You should be familiar with acute, right, and obtuse. Straight angle might be new. That's 180 degrees, or it forms a line. Right angle is 90 degrees. Obtuse is greater than 90, but less than 180. And then acute angle is greater than 0 and less than 90. If you want to find the angle of a measure, the notation is lowercase m, then angle. So again, it didn't transfer right on the left, I just crossed it out. But go ahead, hit pause on this video, find what the measure of angle WXV is, along with the measure of the angle YXW. When you're done, hit play and I'll show you the answers. Here to get the right answers, just look and make sure, is it right angle, obtuse, or acute? So if you look at measure angle of WXV, that's an acute angle, so you're going to use the bottom numbers here since that's the smaller, and you should get 30. Same thing is true for measure of angle YXW. That's an acute angle, so in this case I want to use the top of the numbers, and that looks like it's 150. We saw the same notation here yesterday with congruent segments. Here you have congruent angles. It's used an arc mark. You can see very lightly here in the red, right here in the corner. There's 2 arc marks. When you see that, that means these angles are congruent and therefore have the same measure. And kind of the bulk of the lesson is the angle addition postulate. This is saying the two smaller angles, this one plus this one, is going to give you the larger angle. So just like with the segment addition postulate, the two smaller parts add up to the whole. The last definition is angle bisector. Anytime you hear the word bisector in geometry, it just means it splits something into two congruent parts. So an angle bisector splits an angle into two congruent angles. So here, angle LJK and angle KJM are now congruent. I'll let you go ahead, try this example out, hit pause, go through it, and when you're done, hit play again and I'll show you the answer. Since the angle here was bisected, you can set the two smaller angles equal to each other and solve on out, and when you do that you get x equals 6. However, that's not what the question's asking. It says find the measure of angle JKM, and when you do that you need to plug 6 back in. 4 times 6 is 24, plus 6 gives you 30 degrees. Hopefully this helps you. If not, you can go back. You can always rework something out. Ask me questions if I didn't explain something well enough to you. But you can go ahead, start the homework. It's page 24, and it's numbers 4 through 44 by 4s.